when you've had problems in the past that dealt with a lot of fractions, what you guys always did was just kind of shudder and just get scared and run away and hide and hope that it never comes back. Now, I don't know if you remember this, but there was a shortcut when you're dealing with fractions. And this only works because of this one crazy symbol in the middle, equals.
Oh.
What's the common denominator of a 3 and a 4? 12. Everybody agree?
Yeah.
So what happens here is that I can take this equation now, and if I multiply one side by 12, I have to multiply the other side by 12. Remember, when you multiply one side of an equation, if you multiply the other side by the same amount, the equation still holds true. Yeah?
Could you just call like equal the denominator equal to 12 instead of multiplying the entire thing by 12?
In essence, kind of what I'm doing. Because to turn the 3 into a 12, we have to multiply it by.
4.
To turn the 4 into a 12, we have to multiply.
Multiplying the entire equation by 12.
Just wait, you'll see what I'm talking about. Watch. Now, this becomes a distribution problem of 3 parts. Do you agree? Well, here, here, and here. I'm going to walk through showing the actual distribution step each time here for the first few of them. After a while, you're going to start to see what is going on, and it picks up rather quickly. Here's what happens. You get 12x over 3 plus 12x over 4 equals 12 times 7 over 4.
So you don't do it in the denominator? Oh, because it's 12 over 1.
Correct. Now, each one of those individual terms now are monomials. 12 times x divided by 3, that's a monomial. I can simplify that. What's 12x over 3? 4x.
Oh, dang.
What's 12x over 4? What's 12 divided by 4?
3.
What's 3 times 7?
21. You didn't know.
Where'd the fractions go?
Tomorrow?
What happens here is by multiplying both sides by the common denominator, the fractions go away. This only works with the equal sign. This only works with the equal sign. Now, what's 4x and 3x?
7x. X equals 3. No. If you did.
What's x?
3.
Again, what we have done here is by multiplying by the common denominator of 12 to all 3 terms, the fractions go away.
Okay, what sign is it?
What sign where?
You said it only works the equal sign.
Oh, you can't multiply, what we were doing yesterday with these things, you just can't multiply everything by the common denominator, the fractions go away. Because there's no equal sign. You have to do, whenever you're balancing an equation, you have to do one side to the other. These didn't have a balance beam, there was no equal sign. That's why it didn't work. It only works when you have this equal sign. That's why I try to reiterate, you can only do this with it when you have an equation, when it says solve. If it says simplify, you can't do it.
It says spaced out for some reason if I was addition signs, so then for equal sign, it was really
Yeah,
confusing.
there's 2 lines that just parallel.
Yeah.
Okay? Let's show you another one. Same basic principle. I'm starting with numerical denominators here. I'm starting with the numerical denominators to help build myself out of this. I have x over 3 minus x plus 2 over 5 is 2. 2 over 1, that's fine. If you want to throw 2 over 1 over here, I have no problem with that. Sometimes it helps students to keep things clear. After I get that far, I have to figure out what the common denominator is going to be between a 3, a 5, and a 1. What's it going to be? 15. Good. Again, 3 and 5 have nothing in common. They have no common factors. To get the common denominator, you just multiply them together. So that means if I multiply everything by 15, my denominators will go away again. I'm going to show the secondary step of how this works. I'm distributing 15 to all three parts. I'm multiplying it to both sides of the equal sign. I have 15x over 3 minus 15 times the quantity, x plus 2 over 5, is 15 times 2. Again, each of those terms will now be able to be simplified prior to combining like terms. What's 15 over 3? 15 over 5. And what's 15 times 2? 30. Now, have the fractions gone away? Okay, what do? We solve. Distribute and solve. Exactly right. When I distribute out, I get 5x minus 3x. Be careful here. Minus 6 is 30. Most people will forget and make that term positive 6 by mistake.
That's where you made fun of me.
I didn't
for being.
No, it's serious, and that's where you're going to make a mistake. Just be careful with that step there. Okay? Combine your like terms, we get 2x is 36. I get 18.
Undo that.
It's not that bad, is it?
That's what I thought.
We still have like 25 minutes. Is this getting no? Come
How am I
on.
gonna wait? Come on,
We haven't done. It's worth it. We haven't seen anything with the denominator of a variable yet, have we?
We don't need to, though.
Yes, we do.
Gabby, I'm with Gabby on
I
this
know,
one.
but I had plus 6.
Gabby,
Okay.
you should be-
Take a minute and solve that.
No.
Take a minute and solve that. Do this one on your own.
You did it wrong. You did it wrong.
Do this one on your own. What are you going to multiply everything by? 3.
3 halves.
You don't have to go. Remember, this is over 1. This is over 1. All right. Multiply everything by 3, guys. Now, I'm going to start to get rid of that secondary step a little bit, just so you guys get the idea of what's going on here. This one didn't have a 3, right? So I got to multiply it by 3. So I have 3 times 3x. This one had the 3, so I just keep it there. This one didn't have it. So you have 9x, and x is 15. You get 3 halves. 10x is 15, divide out by the 10, you simplify it out, you get 3 halves. Again, identify what the common denominator is going to be, multiply everything by that, and the denominators go away. This same exact process to doing this still allows you to do this. It doesn't change. It doesn't change. Instead of seeing numbers, I'm going to see variables. I might see terms. And again, what I mean by terms, it might be like x minus 3, x plus 4, something might have to be factored. But here I have 4 over x plus 5 over 2 is negative 11 over x. Make sure you put that negative symbol. I don't know why the book always does this. Let's put it up top. It's a little bit easier to see. That way you don't forget it's negative. What's that? You got it. Can any of those denominators be factored?
No. No, they can't.
You're right. They can't be factored.
No.
So what happens here is that there's an x already, and there's a 2. Multiply them together and you get 2x. Your common denominator here for everything to have the same would be 2x. That would be the common denominator. So you multiply each individual term by 2x. I'm going to show this secondary step again to show you guys what this is going to look like as you distribute out. 2x times 4 over x plus 2x times 5 over 2 equals 2x times negative 11
Negative 6. I
Bro,
wrote
yeah,
it.
no, I
No,
said
I-
no.
You got it right. Hold on a second.
He's lying.
Again, very similar to the other problems we have done, each one of these individual parts has something that'll simplify out to let us get rid of our denominators. Notice, in this first group, what goes away? The x's go away. You get 2 times 4, which is 8. The next group, what goes away? You get 5 times x, otherwise known as? The last one, what goes away? You get 2 times negative 11, which is?
Negative, what?
You get negative 22.
I knew it, but I couldn't.
You're just very excited that you got the problem right. I can understand it. It's okay.
It's negative 6.
Subtract the 8.
He said it.
You get x is negative 6. Yes, sir.
For all of these, wouldn't it be easier to just, if they have the same denominator, like subtract 4 over x from negative 11 over x, and then it'd be negative 15 over x, and you can just cross multiply?
You can. That's fine. If you want to set it up that way, if you happen to have a pair of them that works out that way, I have no problem with that. There will be times we do have fraction equal fraction where that'll come up. Shh, guys. I'm just showing one way to get rid of all the fractions. Sometimes it's quicker to do that, especially if you've got squared terms. When you're cross multiplying, then you have to do some factoring. By doing the common denominator, it usually drops stuff out. But no, there's no problem. Right? Okay? Again, exact same idea. Now, instead of dealing with having an x as a denominator, I have a term. Remember, when I'm talking about terms, it's x minus 2.
Why did you?
I
couldn't the book just write?
Yeah, why did it have to be backwards?
Then write it on the other side.
You're so not cool.
Here, I'll flip it for you, okay?
No turning back now.
I'm flipping it.
I already wrote it.
Yeah.
There, you happy?
Oh, that's so bad for the board. That's so bad.
That's
Yeah, these boards have been on this 3 years on these.
Just
that language.
The board has no chance right now.
Oh, see, I thought that was x minus 5 when you had it.
would have been 5 minus x.
More like 7.
8. Anyway.
Hey, Mr. Murphy.
Wait, when you look at this one, what's the denominator of the 7? 1. So, looking at this problem, what would I have to multiply everything by to get rid of all the denominators? X minus 2. So I multiply both sides of the equation by x minus 2. I get the following. 5x, x minus 2, over x minus 2 is 7 times x minus 2 over 1 plus 10 x minus 2 over x minus 2. The only reason why I'm writing out this secondary step is just so you can see why these things drop out, why the denominators go away.
Can you drop out x minus 2?
Yes, and that's why I'm showing this. As we get further into this, starting probably after this problem, I'm going to stop writing this step. If you want to stop writing it now, that's fine. Because you'll notice now by multiplying out everything by x minus 2, it goes away. I get 5x is 7x minus 14 plus 10, because those drop. And now I have an equation with variables on both sides.
X equals 2.
4 is 2x. But if you substitute back in the 2, what happened?
It doesn't work.
It doesn't work.
Yeah.
Why? Wait.
What do you do to
If I substitute back into here, what happens? I divide by 0, bad things then, right? So after we did all of this, no solution.
Oh, the universe collapsed.
The universe collapses in upon itself.
And 5 puppies are killed.
Yes.
A lot of them are
One of the reasons why, when you're dealing with these types of problems, when you have fractions and you're solving equations, you will always see the instructions, check for extraneous solutions. This is that extraneous solution, where you will get an answer, but the answer doesn't work. And the problems we've done previously, everything worked out cleanly. Nobody ever really mentioned anything, nobody said any word about it. But now when you get to here, you recognize that if you have 2 there, it's not going to work. So remember, when you're solving these equations, since there's all these fractions involved, to always, always, always double check if that solution works. Sometimes it does, sometimes it doesn't, especially if you have a factor. Yeah?
Does it not work in like problems have extraneous solutions in the real world?
I think so. I would say so.
What'll happen is if you have like a quadratic and you're solving out to get a solution that has a quadratic, you know how you'll get 2 solutions? One of them sometimes doesn't work. You'll get something like that. You'll see that a lot of times if you're dealing with a quadratic in geometry. Some weird willy-nilly reason when you have side lengths that happen to be this one is this much, minus this, if you're setting up an algebraic equation, where somebody doesn't know how to use a tape measure and they're really, it's a long-winded book problem. So in a roundabout way, no, you don't have to worry about extraneous solutions in the real world.
IRL.
IRL.
In real life, IRL.
Yeah. I thought it was the indie racing.
Oh no, that's only in Indianapolis.
Indianapolis is in the state.
Yeah, but it's a city. It's still a place. You would use a star for that.
Hey, it's Friday. All right, let's make this more difficult.
Can we do like one more?
Again, this is about as complex as this gets, where you have to do something to one of the denominators. What do you have to do to the denominator here? Oh, I'll just write this down first, sorry.
Why do you keep writing backwards?
I didn't do this, I just cut and paste.
Oh, too lazy. I don't even have sunshine instructions.
All right. Now, I'm going to put this 3 over a 1 so we don't forget that it's a numerator. Now, as I go through this, I can't factor the x plus 1. Can I factor the x squared minus 1?
Yes.
What do I get?
X plus 1, X minus 1.
What I'm going to do is just rewrite it here. Now, between those 3 different denominators, what becomes the common denominator?
1.
X plus 1, x minus 1. Again, this is mirroring now our 1/4 minus 1/6. They both had a 2 in common. We wrote it down. What was left over? A 2 and a 3. We filled it in. Here, they both have an x plus 1 in common. So we write it down. To fill in the gaps of what was left over, we had to multiply it also by an x minus 1. It follows the same exact rules as 1/4 minus 1/6. You're getting that least common denominator. Yeah?
So you're multiplying it by x squared minus 1?
I am, but I'm not going to multiply it by x squared minus 1 because now you'll notice when I distribute this in, the x plus 1 drops out. This all drops out, and I have an x squared minus 1 over here. Okay. It's not stupid. It's just math. It's complex honors algebra 2 solving multi-step equations. Again, I'm going to be distributing out, but I'm not going to do the intermediate step here. If I distribute x plus 1, x minus 1 to the first fraction, it's already sitting on an x plus 1, so what do I just have to multiply it by? Good. So I have 4x plus 1 and an x minus 1 equals. Do I have to do anything to the 12? Nope. But to the 3, I have to multiply it by the x plus 1, x minus 1. Do you agree? Wouldn't it be easier since I have to distribute just to write it as x squared minus 1? Is that okay? again, this last fraction, the 3 over 1, it doesn't have either of the common denominators. The common denominator was x plus 1, x minus 1. And since eventually I'm going to have to multiply all of this together anyway to solve for x, if I just multiply it instead of by x minus 1, x plus 1, I know that's x squared minus 1. Can I just write that? I'm just making my life a little bit easier. That's all. I'm just saving myself a step. FOIL out. 4x squared minus 4x plus x minus 1 is 3x squared minus 3. So 12 minus 3 is plus 9. And almost done. Variables on both sides of the equation, what are we going to do?
Like terms.
We're going to combine like terms. Which way are we going to send everything? To the left or to the right? Go left because your 4x squared is greater than the 3x squared. You will have a positive first term. So we wind up with 4x squared minus 4x, or excuse me, minus 3x minus 1, and I'm going to subtract 3x. I'm going to subtract 9 to set this equal to 0. X squared minus 3x minus 10 is 0. Back. Yeah. What times what's negative 10? Negative 3.
Negative 2.
Negative 5.
No. Negative 5 and 2.
So what are your two possible zeros for this one?
5 and negative 2.
Again, what should I do real fast?
Check it.
Check it. 5, okay. 2, you'll be fine.
Looks so good.
Sometimes you'll have more than one solution that works. Again, all we're doing here, guys, getting the least common denominator, whether it's just multiplying the two denominators together to get it, or factoring it out to their common terms to get it. All right? What we're going to do then for this as far as the homework is concerned, I think I have 4 problems.
Just about 4.
Yeah. Because I want to take a minute here to give you guys some instruction about what the weekends, what I want you guys to look at over the weekend. So it's on 571. Now what we're going to do on Monday is that we're going to come into class, we'll take 10, 12 minutes to go over these 4 questions. I don't think it'd take more than that. After that, we're going to have our quiz. I'm going to put the quiz to Monday instead of being it on Tuesday. It's going to be, I'm not sure exactly what I'm going to classify it as yet, it's a quiz or a test. It's just going to be over these last 3 sections, and it's 5 questions. That's it, 5 questions. I'm going to give you guys the last 30 minutes or so of class to do 5 of these problems. You should be done with them in about 13 minutes. Seriously, 15 minutes tops. How did I do that? All right. I'm trying to I set this up, thank you very much. I'm trying to set this up in such a way to get you guys a little bit more time as far as the review is on the final. With that being said, I've already emailed out everybody a copy of the PDF file of the review packets, along with a real fun note for your parents, so your folks will probably annoy you with it.
Hi, how are you?
Yeah, exactly. That's great. What I would suggest you guys do, I've got these 4 problems, and then in the review packet that I have, the very last 6 problems in this are also from these 3 sections. I would do those over the weekend as well. Now, the review packet that I made is a couple of problems, basically, a couple of problems from each of the sections we've done throughout the first semester. Yeah. And what I did was I created the answer key at the very end. So you can check all of your answers to see if you got it right. It doesn't tell you how to do it, but at least you can check to see if you're on the right track. No, all your answers are here. Okay.
What one did you want us to do?
On this, again, on this here, on the very last problems here, is I'm suggesting that you guys look at numbers, let's see,
Pretty answers.
the last couple pages.
I like the word.
Is that funny?
So, the review packet,
Working alone.
numbers, this is great, numbers 119 through 124. Those are also the same style questions from
Why are
these,
you laughing?
because there's 124 questions on this.
There's actually 28.
Oh,
Yeah, there.
oh, jeez. All right, so one.
Wait, is this due? No.
Again,
No, but you should
I
do
gave
it.
you all of the answers.
You should do it, but it's not.
What I'm saying here, hold on. What I'm saying here, guys, is that these are the 4 problems I'm going to focus on first thing Monday morning. If you happen to have a chance to try out a couple of these, it would be a good idea. It's just extra practice of the same stuff you're going to have a quiz on Monday. Quiz is 5 questions. After that, if there's any time left over, we'll start going through the packet. That way we're leaving out Tuesday, Wednesday, and Thursday to go over all this. What stinks for you guys is the unfortunate fact that your final isn't until the following Wednesday. So you've got a 5-day break between.
So we should almost wait to do this till the week.
Like
next week.
Right, you're going to wait that long.
Well, then it's
What I'm
fresh
going
on
to do,
our mind.
but what I want to do here is use the time in class to start working on it, start going over the questions here that'll happen. I know there's going to be a lot of questions about exponent rules, factoring, things like that.
Exponent.